Hey. Welcome back to part number 3. Last time in part number 2 we connected to our MQTT message broker, transferring some data, and today we will show this data on the Pimoroni display and play with this display a little bit. Let's start straight away. Okay, let's integrate the Pimoroni libraries. And as we baked in all the libraries in chapter 1, so we took the Pimoroni firmware, we can simply, not import, sorry, we can simply from the Pimoroni library take the RGB LED. So we can play with the LED itself. Then we can take buttons, however, at the end we won't use them, and the simple reason is that we want to use interrupts, and this library of Pimoroni doesn't support the interrupts. So that's why we take from the machine library, so from the normal or default library of MicroPython, the pin, and we will use pin instead of button. However, both would be possible. And last library we want to take is the Pico graphics library with the Pico Display. Okay, the first thing you have to do is to place the Pico Display on your Raspberry Pico. Take a look at the USB icon on the display itself, that you put it the right side, and take a look at the pinnings like I did it here. We don't want to get into details, I think that's easy to do. On this page here, I will set a link, you find all the examples of the Pimoroni, and that's quite helpful just to see what it can do. I will show you maybe the balls demo here shortly, and of course also the other demos are quite helpful. Just check them out, you just need to flash them into the display, that's all. I opened now the example button test from Pimoroni, and you can see that they use a button class from the Pimoroni library, and we won't use that because the simple reason is we can just copy this one here to our program, but the problem is that it can't deal with interrupts, and I want to use interrupts. You will later see why. So what we change is simply that we will use the pin library, which we also imported, and this is working, so no worries. You can simply use the normal pin library with the import definition, and in this case it's a pull up, and we can do this now for all 4 buttons. Now I open the thermometer example, and let's copy the sensor temp, so that's the ADC converter pin which we need. Let's put this somewhere here for thermometer definition, and we also take the conversion factor which we need for the conversion of the ADC values. So after converting it, the analog value to a digital value needs to be converted, of course, by the resolution of the converter, and we take this from the examples here. We don't need min, max, and so on, because I don't want to have a chart created, but take a look if you're interested in the demo. Always something you can learn here. Okay, and now let's create our display connect function. So the last missing piece in our breakthrough from getting our data from MQTT to our display. So we call it display connect. And we should set some variables here again. So first the display variable, and during startup I want to set the RGB so that you can see that they are illuminated. Let's define the RGBs first. So we need to set the pins, which is 6, 7, 8. That's the Pico Display pins, and we also, I don't need it actually, but I want to take it anyway. I want to get from the display itself the information about the bounds, so the boundaries. We need to set the display backlight. While 1 is equal to 100%, you can set it to 0.5 for 5% and so on. Okay, next thing we need to do is to set a font. By the way, this is the default font anyway, so this is optional. More important is to set a pen, and to set a pen you need to create a pen. You can create pens and align them to variables, but I do this in one function now and create a red pen 25500 RGB red. I clear the display and the display gets red now. Now I set the LED to red and I create a new pen color, and this is now white, and I want to set a text, and this text is waiting for data, and you need to define 4 parts, 2020 124. The last one is the font size. The before is the wrapping, so when should it wrap to the next row, and the before is X and Y coordinate for the position. Another create pen afterwards, again to red, and we update the display and we return display LED width and height. As said, I don't need width and height, but let's take it also to the main, back to the main. So we had some little typos in when we call this function now. We will get 2 errors, I think. So we take new variables in the main, display LED width and height, and call it. And first error is that we had set reg, so it should be first of all LED set, because LED is the name, and not reg but RGB. So 2 typos in one. And when we now start it, we see that our display gets red and waiting for data. Okay, next thing we want to do is after the first message is received, we want to set the LED to off, which is nothing else than 000. And now we want to do something when the first message is received. Currently, you see already that I get messages here. This is from our last part, MQTT connect. We get some messages, wind speed, and so on, or we create already the variables. Now we can print this on our display. That's the next thing we want to do. Okay, so for that we simply will again create a pen, and in this case it is black. Why? Because we want to clear the display. That means the complete display gets black now, so the background gets black. Only if we update the display, but we can do this step by step. Now we set the display pen back to white. Why? Because I want to write something on the pen itself. And we write on the pen our, let's say, wind speed, okay? So we say wind, and we put the wind speed in our string. We add the wind speed. We put it on the top left corner. We use a wrapping size of 240, which is the maximum length of our display. So it means there's no wrapping, only if it's too long. And we use a font size of 3. And the last important part is display point update, because otherwise the display would still stick to the red what we did last time. That's all. Let's go and let's run our routine. And we get after the connection the wind speed. What we also will do now, after each callback, we will grab the latest sensor temperature reading, multiply it with the conversion factor, and then we will convert our reading to degrees Celsius. And in temp pico, we have the reading of the Pimoroni display, because it has its own temperature sensor. And I will add this information here also in the text, so that we get also the temperature of our Pico. Okay, and we're waiting for data. When the data is there, we should get the temperature reading of, here is it, of our Pimoroni display, of this own sensor, onboard sensor. But now we want to take a look at the buttons and use the buttons of the display. To do so, we need to define buttons. Let's say we define a button A, and I want to set an interrupt. Why? Because my problem is, if I wait here in the client wait loop, I can't detect a button press. So I need an interrupt so that I can detect this outside the loop. We will trigger on the falling edge, but this is both is possible, let's say. And we will do this for all 4 buttons. We will in all 4 cases for B, X, and Y start or access the interrupt handler. So the handler is now a function. So we need to define a new function here, which is called interrupt. Okay, and we will simply print button pressed, and in another row the button itself, so which we get from the callback routine or from the interrupt routine. And let's go. So we press X, Y, A, and B. Okay, let's do another exercise. Let's assume we want to use button A for getting the brightness up and button B for getting the brightness down. So I will use different functions now. So we copy this function here and we call this A. So we keep the other one for the other 2 until we have an own function for them. Now we want to call this button A pressed. We don't need to print this. And what we want to do is we want to change the backlight. I need a global variable now, which I call backlight. To have a global one, I need also to define this here. And not as global, I just write backlight and I set it to run. So this is 100%. We had this topic before. So that's our start. So full backlight. And we have a spelling mistake here. It should be backlight, not blacklight. And let's put this also on top of our routine here. Okay, now let's check if the backlight is below 0.85. And if this is the case, yeah, so if the backlight is below 0.85, we increase the backlight by 105. I took 105 steps. You can also take something different. We set the backlight now and we do the same, not exactly the same, but more or less for the B button. In this case, we will decrease the brightness, and so we check if it's above 0.85. And if so, we will decrease it. For the top, we should have a small or equal. So we press button A first, and we see it says press, but nothing happens. We press now button B, and we see it's getting darker. A again, and it's getting brighter back to 100%. Okay, now let's use button X and Y to browse or scroll through different screens. We will change our default interrupt routine here to X, and we will create one for Y as well. And we use this one now to set a variable which we can use to know on which screen we are. One is increasing this variable, the other one is decreasing it. For that, we create the variable interrupt flag and set it to 1. We're going back to our function here, and we also let the function know that there is a global variable interrupt flag existing. Now we increase, because that's our X button, the variable interrupt flag by 1 when this button is pressed. However, we need to check if we are not above a certain value. So let's say we want to have 2 screens. So we check if it's above 2. And if so, we set interrupt flag back to 1. Okay, we do the same now. And maybe we print it so that we can see if this is working. Print our interrupt flag here. And we do the same for Y. But of course upside down, so we want that our interrupt flag is reduced by 1. And we check if it's smaller than 1. So if it's 0, we set it back to 2, so our last screen. Okay, let's start it and take a look what happens if I press X. It says button 1, press in 1, 2, 1, 2, and button Y is 1, 2, 1, 2. Okay, it's always switching between 1 and 2 because it's just these two buttons. Maybe it makes more sense if we increase this by 1, that we say, okay, we have 3 screens, and then we have to set it also to 3. Let's do another run. And when we now press X, we see, okay, 1, 2, 3, 1, 2, 3. And if I press Y, 2, 1, 3, 2, 1, working. So why did we do this? Because now when our callback from the message starts, we can use this interrupt flag to write different information, so we can use more than one display. I will prepare something and we'll take a look at this together. Okay, what did I do? So first of all, I used our callback routine and created a global JSON variable, which is also defined here on top. So we have now a global JSON. Why? You will see this in a second. By the way, it starts with none, so undefined. We decode the JSON, and then I go to draw now. And then draw now, I check the interrupt flag, and if the JSON is defined, and if it's defined, we start the draw 1, draw 2, draw 3 function, or we give the feedback that there's no data yet because the JSON is not defined yet. Before we check the draw functions, in the interrupt X and Y routine, I also call draw now, so that when we switch the screens, we have a direct action and a drawing. So let's take a look at the 3 draw functions. It's more or less the same what we did before. I just wrote screen 1 on top, and for 2 and 3 I did nothing except screen 2 and screen 3, so that you see that it works. Let's start. And you see if I press X now and there is no data received yet, I get the message that there's no data. When we transfer data, we get the last screen, 2 in this case. I can go to 3, 1. And you see screen 1, 2, I can go down and up and so on. So that's how this is working. Of course, you can add now several data on your own. All sources, I got my solar sources, as I said last time, but also from my BME 280 sensors and so on. So take whatever you like, use the display, use MQTT. And I hope you enjoyed this nice round trip from Wi-Fi via MQTT to our display. Okay, this was the last part number 3 of our journey from our Wi-Fi connection via MQTT to our Pimoroni display. I hope you enjoyed it and see you next time. See you next time.